Hi everyone, this is Abdul from Pythonist. We have learned a lot throughout this journey to make our Python code much more efficient. We have talked about the importance of profiling to pinpoint the performance-related issues in our code. We understand the mechanism behind lists and tuples, how dictionaries and sets can help us in this regard. The discussion about vectors and matrix computation was also very interesting. And we also talked about to bring the performance of C inside Python. And even we get our hands dirty on concurrency and multiprocessing. What a great journey, full of great discussions. If you haven't watched that playlist, believe me, you are missing something great if you're a Python lover. Go ahead and watch this playlist. Now from this video, we will continue our journey to achieve even more to provide a much faster experience to our customers and users. So we will talk about the clusters and job queue in a few upcoming videos. Let's start with the clusters. What is a cluster? Why clusters are so useful? What should we consider before choosing clusters? And how we can convert the multiprocessing solutions into a clustered solution? Let's try to answer these questions. So a cluster is commonly recognized to be a collection of computers working together to solve a common task. It could be viewed from the outside as a larger single system. GCP has a bunch of great examples of how they have implemented clusters of hardware infrastructure to ensure the reliability and availability of their services. AWS is commonly used both for engineering production clusters in the cloud and for building on-demand clusters for short-lived tasks like machine learning. So what are the things we should consider before moving to a clustered solution? Before you move to a clustered solution, do make sure that you have profiled your system so you understand the bottlenecks you have to overcome. Make sure that you have utilized compiler solutions like cython or numba, exploited multiple cores on a single machine using the multiprocessing techniques we discussed earlier in this series. Make sure that you exploited the techniques for using less RAM. Keeping your system to one machine will make your life easier. Move to a cluster if you really need a lot of CPUs or the ability to process data from disks in parallel, or you have production needs like high resiliency and rapid speed of response. But why clusters are useful? What benefits will we get? The most obvious benefit of a cluster is that you can easily scale computing requirements. For example, you can add more machines or nodes if you need to process more data or to get an answer faster. By adding machines, you can also improve reliability. Each machine's components have a certain likelihood of failing, and with a good design, the failure of some components will not stop the operation of the cluster. Clusters are also used to create systems that scale dynamically. Dynamic scaling is a very cost-effective way of dealing with non-uniform usage patterns. As long as the machine activation time is fast enough to deal with the speed of changing demand. Let's discuss the critical consideration you must think about. Moving to a clustered solution requires a change in thinking. This is an evolution of the change in thinking required when you move from serial to parallel code. Certainly, you have to consider what happens when you have more than one machine. You have latency between machines. You need to know if your other machines are working, and you need to keep all the machines running the same versions of your software. System administrations is probably your biggest challenge. Also, you normally have to think hard about the algorithms you're implementing. And what happens when you have all these additional moving parts that may need to stay in sync? This additional planning can impose a heavy mental tax. It is likely to distract you from your core task. And once a system grows large enough, you will probably require a dedicated engineer to join your team. Another important thing to consider is the consideration of some important questions. When designing a clustered solution, you will need to remember that each machine's configuration might be different. How will you get all the right data onto the machine that's processing your job? Do the latency involved in the moving job and the data amount to a problem? Do your jobs need to communicate partial results to each other. What happens if a process fails, or a machine dies, or some hardware wipes itself when several jobs are running? Failures can be introduced if you wouldn't consider these questions. And another thing is that you must have to accept the failure. You should also consider that failures can be acceptable. For example, you probably don't need 99.99% reliability when you're running a simple web service to serve your content. If a job fails and the user is required to reload a page, that's something that everyone is already used to. It might not be the solution you want to give to the user, but accepting a little bit of failure typically reduces your engineering and management costs by a worthwhile margin. On the flip side, if a high-frequency trading system experiences failures, the cost of bad stock market trades could be considerable. The last thing I would like to mention here is that the clustering can be expensive. Maintaining a fixed infrastructure can become expensive. Machines are relatively cheap to purchase, but they have an awful habit of going wrong. Automatic software upgrades can glitch, network card fails, disks have to write with errors, power supplies can give spiky power that disrupts data. The more computers you have, the more time will be lost to dealing with these issues. Sooner or later, you will want to add a system engineer who can deal with these problems, so extend your budget too. Using a cloud-based clusters can mitigate a lot of these problems. It costs more, but you don't have to deal with this hardware maintenance. And some cloud providers also offer a spot-priced market for cheap but temporary computing resources. I have too many examples to quote here. Skype suffered a 24-hour planet-wide failure in 2010. Behind the scenes, Skype is supported by a peer-to-peer network. An overload in one part of the system caused delayed responses from Windows clients. Approximately 40% of the live clients crashed, including 25% of the public supernodes. With 25% of the routing offline, the network overall was under great strain. Skype became largely unavailable for 24 hours. The recovery process involved first setting up hundreds of new mega supernodes configured to deal with the increased traffic, and then following up with thousands more. Over the coming days, the network recovered. This incident caused a lot of embarrassment for Skype. Clearly, it also changed their focus to damage limitation for several days. Customers were focused to look for alternative solutions for voice calls, which was likely a market boon for competitors. I believe that now you have a better idea of what a cluster is, why it can be useful, and what are the things critical to consider in this regard. Feel free to post your questions and thoughts in the comments below. I think that's enough for this video. In the next video, we will talk about how to design a cluster, and we will explore some clustering solutions specific to Python. So stay tuned, and if you like the content of this video, give us a thumbs up and be sure to subscribe to my channel and hit the bell icon so you will never miss any fantastic video in the future. Thanks for watching.